My version of the installation of ESU's select Micro 4 decoders into Kato N-scale diesel locomotives. I've purchased several sound-equipped N-scale locomotives for my fleet in the past. Recently I was introduced to ESU's Lok Sound decoders and the audio they're able to produce in retail locomotives. To say the least, I was impressed with the improvement on the quality of the sound over previous sound decoders I had heard in the past. A while back, I purchased two ESU Lok Sound Micro 4 select decoders with the TDS supersonic micro speakers. Follow along as I present my conversions on my version of the install. While these ESU installations have been completed before, I don't know of anyone that has completed it in the way that I have. As I mentioned, I wanted to make the conversion, but in addition, I wanted to try a different method to install the components and make the installation a bit easier and more sanitary as far as the overall installation of the speaker, lights, and wiring. Allow me to fasten all the components to a slightly modified frame mechanically. Using a pair of digital calipers, I measured the Kato body shells and frames at a few points for reference, and then started clicking the mouse on my computer within my favorite CAD program. It didn't take too long before I had a drawing of something I thought would work. Follow along as I go through the steps in this process. After taking the body shell off the first locomotive, I removed all of the drivetrain from the frame. Next came a warm soapy bath to remove any dirt and oily contaminants from the frame halves. Now I needed to put my plan into motion and to see if it worked to my satisfaction. I started with an FR4 1/0 single-sided copper printed circuit board 20 thousandths thick. After tracing a few lines in the copper face on the board, I started cutting out the board I would need with a jeweler saw. Using a machinist vise to hold and create a straight edge for the saw, I cut the board several times to create the board size I needed. Here you can see some of the progress I'm making with the saw and vise to form a board into the functional spine for mounting the components. This is the rough outline of my conversion board. A few more things need to be done before it's ready for the components. Here I'm laying out the grid for the speaker baffle holes. Contrary to the caption in the cartoon, this is a good thing. Here I'm pre-drilling the speaker baffle holes with an undersized number 71 drill to be followed by a final number 56 drill. I knew the printed circuit board would help me place the speaker, rear LED, required resistors, and would help me mount the front LED, but how to create the traces on the board. Never fear, YouTube is near. I made a few searches and found a crude but effective method to make the board traces I needed, at least on a prototype version or two. The method has some hazards, but all the chemicals are readily available and can be disposed of at municipal recycling centers. The hazards are from the iron chloride solution and the acetone used in the process. Always use goggles or a face shield, protective gloves, and keep exposed skin covered from the iron chloride or acetone. In addition, iron chloride is extremely corrosive. Remove jewelry, watches, and keep valuables containing metal away from the iron chloride. This is a view of board number 1 before the etching. I prepped the board with acetone to clean the copper surface for the trace mask. I used the Sharpie marker to create the mask. While the lines are crude and not as neat as I would like, they will work. I recorded a video of the etching process for your reference. At this point in the initial prototype photos, the documentation went non-linear, so I've mixed pictures from both the first and second prototypes, and the timeline gets blurred. The next short video will demonstrate my method of milling the frame with a jeweler saw to make my conversion possible. I've chosen not to put the frame assembly into a vise, as I've had trouble working frames that way in the past. However, I've sandwiched several printed circuit board pieces between the left-hand and right-hand pieces of the frame. I then used the stock hardware to assemble the frame like it will be once it's reassembled. The printed circuit board pieces will help prevent warpage or distortion in the two frame pieces during the cutting. I then started on the speaker cabinet for the TDS supersonic speaker. I made a few measurements of the speaker and I checked my available styrene supply. I then determined what I could stuff into the available space under the body shell and the conversion printed circuit board. At this point in the build, I've got the items in the picture ready: the milled frame, the speaker and cabinet, the motor power clips, and the homemade printed circuit board. I've gotten to the point where my surface mount, technology components, and printed circuit board are ready to come together. But first I'll create a conductive path for the audio signal to get to the speaker. On the printed circuit board, I drilled a hole in the speaker pad and passed a wire through as a way to create part of the path to the speaker connection tabs. After I formed the wire, I soldered it to the pad and turned the board over to form the other side to be soldered to a small amount of conductive copper tape. Yes, it would have been easier to have double-sided circuit board for this, but as a prototype, it will definitely work. I'm at the stage where more of the fun begins as I start loading the printed circuit board with the 402 surface mount technology components, the speaker and cabinet assembly, and motor clips. I added 1 k-ohm 8th watt resistor for each of the two LEDs I used in this conversion. I wasn't going to mess around with the individual ditch lights at this point in the development. Ignore the yellow wires, they were used for an intermediate test. I had to slow down a little to make sure I had the right polarity for the LEDs. The LEDs were marked, but when you're working with something as small as they are, I had to double check a few times. I found that soldering the 402 surface mount technology components wasn't that bad. I ended up destroying a few from excessive heat, but I expected that. Okay, I'm ready to check the fit of the printed circuit board to the frame and shell. I also mounted the printed circuit board into the frame to check the mechanical fastener designed into the board. To install the board, it needs to have the two tabs for the rail power inserted into the horizontal slots in the frame as per the original contact points. At the same time, the board is flexed such that the forward part of the board is bent upward to clear the same tabs. Once there is clearance for the board to resume its natural flat position, the board is locked into place. I think I have a hard time describing the mechanical fastener, but I believe the pictures will assist you in understanding how it works. Next, I created a mount for the front LED and pad. I found an old piece of printed circuit board and cut a notch to isolate one half from the other. I then drilled 2 holes for connecting the yellow and blue wires. Note that the anode side has a resistor in series and it's mounted on the conversion board. Things look good at this point, and I started wiring the decoder to the pads on the board. I cut the wires to an approximate length and removed the green and purple wires that were no longer needed. You may have noticed I removed the clear heat shrink from the decoder board. This may have voided the warranty, but it was either do that or remove material from the shell for clearance. I'm comfortable with the heat shrink being removed from the decoder board. Well, now it's time to hide the conversion work and put on the body shell. I spent some time on the programming track to get the locomotive to perform to my liking and changed a parameter or two for the bell, horn, and master volume. I will give you a brief demo of the sound and low-speed performance of the locomotives. I wish there was a drop-in ESU decoder board, but recognize that the Kato frame makes it a challenge with some of the current technology. While some conversions have been made successfully with different methods, I know my approach works, and I'll be converting my remaining Kato locomotives when time allows. I will demonstrate the sound card and slow motion of the locomotive with the ESU Micro Select 4 basically in the following order of events. Engine startup, lights on, ring the bell and blow the horn. Using ESU's drive hold function F9, I throttle the engine up through several notches while the locomotive is stationary. I reduce the throttle settings back to idle. With the decoder in ESU's yard mode F7, I move the locomotive in forward and reverse in step 2 of 128. I shut down the engine and turn off the lights. Before I end the video, I want to thank a few guys at Tony's Train Exchange that gave me tips on this conversion. In particular, I'd like to thank Hank and Lewis.